Now, we're now going to be looking at combining sets. And in order for us to properly deal with this subtopic, then we're going to be looking at a question. This question will show you how we combine sets, finding intersection and union and all other things that we have looked at before in terms of complement and a number of elements in a particular set and representing our information in a Venn diagram. So let's say set A is equal to 1, 2, 3 and set B is 2, 3, 4, 5, 6. We're being asked to find the intersection of A and B, the union of the two sets, the complement of A, the complement of B. We're going to represent the information in a Venn diagram, and then we find a number of elements that are in the union of sets A and B. Now, the first thing we're going to be finding is the intersection. So, here we go. Now, to find the intersection, we look at set A and set B, and then we find the elements that are common. Now, I realize that looking at set A, 1 is in set A, 1 is not in set B, so that is not a common element. So, we go to the other element that is in set A, which is 2. We look in set B, it's common, so 2 is one of the common elements of A and B. Then we look at 3 in set A, it's also in set B, so the other element is 3. And then this one is finished. So the intersection of A and B is 2 and 3. Now if you look at the other part that we have for the union, we realize that the union will include all the elements that are either in set A or set B, and we ensure that we write elements once. So if we have elements that are common, we write them once, and the elements that are not common are also taken into consideration when we are writing the union. So looking at set A, we have 1, 2, 3, and set B have common elements 2, 3 as in set A. So we will continue with 4, 5, 6. So when you combine all the elements that are either in set A or B, we get 1, 2, 3, 4, 5, and 6. And that's the union of sets A and B. I know question part 5 asks us to represent the information in a Venn diagram. But what I will do before I find my A complement and my B complement, it can be easily found because all the elements that are in the universal set that are not in set A would be A complement. So you can do one of two things here. You can use your Venn diagram, draw your Venn diagram first, and so whichever approach you take, it doesn't really matter. So if you wish to find part 3 first, you can do that. So part 3 says find A complement. All the elements that are in the universal set but not in set A would be A complement. So we have A complement is equal to, see, we have 4, 5, and 6. So these are the elements in the universal set. They are not in set A. And just to put something right here, you don't have to write the numbers in numerical order. You can jumble them if you wish. But for the most part, students will write the numbers in alphabetical order, and that is still fine. So whichever approach you take. So if you wanted to write 6, 4, 5, that is still fine. We are interested in the elements. Part 4 is asking you to find B complement. Now for B complement, remember these are all the elements that are outside of set B but are in the universal set. And we realize that only the number 1 is not in set B but in the universal set. So if we were to represent this on a Venn diagram, which is part 5, what we will do, we have to have our set A, that is our set A, and then we have our set B, but remember we're going to have intersecting sets because we have common elements for both sets A and set B. Now if you look, set in the intersection that we had up here before, we had 2 and 3, so the number 2 and 3, they go here. And look at set A. After I take out my 2 and 3, in set A only I have the number 1, and in set B I will have 4, 5 and 6. So this is how we represent it on the Venn diagram. So our universal set, the elements in the universal set would be 1, 2, 3, 4, 5, 6. The elements of set B are 2, 3, 4, 5, 6. And the elements of set A are 1, 2, 3. So A only, sometimes we may be asked to state the elements or element in A only. So in this case, A only is 1 and B only is 4, 5, 6. So if you look, if this is set A, the elements that do not belong to set A, which is what we call A complement, see them here, 4, 5 and 6. That's what we have, 4, 5 and 6. And if you look at set B, this is our set B. The elements that do not belong to set B is just 1 alone. That is why we have B complement is 1. And finally, we're asked to state the number of elements in the union of A and B. Now, in this case, since the elements are listed, we can just count the elements to find out the number of elements in A union B. We have 1, 2, 3, 4, 5, 6. So we write the number of elements in A union B, and since we count them up, we got a total of 6. And that is our result for the question.